Yes, ma'am.
Okay, good morning, everyone. Our week 1 and 2 module is entitled gas loss. So, this actually our first module for the second quarter.
Yes,
There's one more module that I need to discuss, pero wala pa na ko siya na buhatan. I-insert lang to na ko siya. Dapat kay after siya sa chemical reactions. So, kay lisod-lisod to siya para ma-orient na mo og mga number of molecules mo nang ako na nang siyang giunadaan nga topic. So this is actually a very very long topic. It has 5 lessons. It has the first lesson is kinetic molecular theory of gases and pressure. And then we have the gas laws, the Boyle's law, Charles' law, Avogadro's law, and the ideal gas equation. When we were in high school, during your junior high school, you were taught of 4 gas laws. Siguro you may wonder why, as of this moment, tulo na lang ka gas laws. That is because the combination of Boyle's law and Charles' law is what we call the Gay-Lussac law, which is redundant na kayo siya because we already know some relationships of some properties. So, manang wala nag-include sa senior high school si Gay-Lussac's law. But Gay-Lussac's law just tells us the relationship of Boyle's law and Charles' law. Since we already have the ideal gas law, so no need of the Gay-Lussac's law. So again, we have 4 gas laws: Boyle's law, Charles' law, Gay-Lussac's law, and Avogadro's law. For this lesson or for this module, we will only tackle 3 out of 4 gas laws. Am I clear? Ayo. Naitaw sa
Yes, ma'am. Yes, ma'am.
Very good. So, our first lesson is the kinetic molecular theory of gases and its property. Now, when you hear the word kinetic, what is the first idea that would come up in your mind?
Moving.
Very good. So, when we say kinetic, it deals with motion. So, when you hear kinetic molecular theory, this might deal with the properties or with the behavior of the molecules or the motion of the molecules of the gases. So what is this kinetic molecular theory? So that is the thing that we are going to learn for lesson 1. Now, I have here a picture analysis. Humana mag-answer aning picture analysis?
Mano, ma'am.
Humana? Kinsay wala pa. Di ba ningon ko before ta magklase, ansiran ang what's new. Oy, naa dito sa ako ang instruction nga pagkahaba-haba dito sa GC. Every time magklase ta, so from now on, every time magklase ta, you have to answer only what's new. After our class, you answer the rest. Am I clear? Ayo. So
Okay,
our class will be lecture, and the next day you will answer. Then the next day we will have the lecture, and then the next day you will answer. Okay?
ma'am.
And then
Ma'am.
yes, because we have 4 schedules in a week. So the first one is for us to discuss. The second one is for you to answer. Dili ko gusto nga mag-answer mo og alas 7 sa gabi, alas 9 sa gabi. You answer during our time. Okay? So, since wala pa man nag-answer ang uban ani, surprise ang discussion anak niya. Ha? So, sige, i-bonus na lang na siya nako. Sa mga wala naka-answer. This deals with, or these pictures shows how the molecules react when they are heated, when the volume differs, and when there is an increase of the number. So this talks about their behavior when there is differences in their properties. So how to describe it inyuhan na ng problema. So gases are quite different from liquids and solids. Why? Why they are different from solids and liquids? So they have so si liquid ug si gas parehas sila nga mo sa gani mo awat sa shape sa ilang container. But si liquid cannot fill the entire container. Nakabantay mo pag namoy liquid na siya mag-curve sa kanang imabaw, we call it the meniscus. Di ba pag tip sa iyahang pag tip sa liquid, ni liquid na may makitaan nga curve sa pinakataas ana niya. Lan tawag gani na ibutang gani ang water sa transparent nga glass. And then focus on the tip, di ba naka-curve siya, we call it the meniscus. So kana siya is the effect of the air pushing the liquid downward. So naagyapoy air content ang container. So it means the liquid can acquire the shape of the container but cannot fill the entire container. Si gases, on the other hand, fill the entire volume of the container evenly. So, si solid, it has its own shape. So, it doesn't imitate the shape of its container. So, kung naa kay cube, ibutang nimo sa circle nga sudlanan, cube ra yung gihapon si solid, it will not change. So, again, they fill completely the container, taking both their shape and their volume. So, what are the physical properties of gases? So, gases can be compressed to a smaller volume and in turn increase their density. Nganong makompress man nato sila? Any idea?
Ang gas, makompress sa smaller volume.
Nganong mag-compress ang gas in a smaller volume? Can we compress a solid? Can we compress? Why, Aljon, we cannot compress the solid?
Kuha naman siya, ma'am. Solid naman siya, ma'am.
Why?
Kaya yung particles tapad-tapad na.
Very good. So it goes down to their distance sa ilahang particles. So when the particles are too close to each other, there is no other way to compress them. While the gases, when we say gases, they are far from each other. So that's why they are highly compressible. Can we compress the liquids?
Yes.
Yes. We can slightly compress them. O bitaw nang nakaygitawag og kwan kanang ice, di ba? If we lower the temperature of the water molecules will begin go closer to each other, they begin compacted, and they turn into solid. So that is because their distance from one molecule to the other molecule becomes smaller. So their physical property or their appearance or their state differs when the distance between molecules differs. Kailan mo og LPG?
Yes, ma'am.
Okay. Di ba pag ang LPG, unsay paminaw ninyo sa ilalom na init bugnaw?
Init.
Bugnaw, ma'am.
Bugnaw. Mapasok na yung mga gunit mo ng kwan. Magunit mo sa tank niya, mapasok mo? Di ba dili?
Ma'am, wala mo ni Ana.
Ilalom sa LPG, bugnaw.
Adoro ng puan, kahoy.
So, tawag siya liquefied petroleum gas. So, ang gas liquefy. So, nga nang giliquefy siya because the distance between each molecule of the gases are decreased. So, they are compressed under high pressure. Diba? Pag imo siyang abrihan, burag na ay gawas nga pressure. So, under high pressure, matong compact sila. So, gases are highly compressible. Next, gas fill their containers uniformly. So, dili parehas sa solid kung asa mo siya gibutang sa container, tuara siya dito lapita. Or ang liquid, na siya'y menisco sa taas, na siya'y curvature sa taas for the air. So, while the gases, they fill all the spaces of the container. Gases, naunsa man ako spelling sa gases, na gas. Gases are exert pressure. Now, in what way gases exert pressure? The thing is, do you know what
Mainitan mo.
pressure? Unsay pressure?
Magkuan og dako na force or dako na
Very good.
lagi.
Force. What else? Unsa pa ka high factors nga nag-involved og pressure?
Heat.
Bang. Okay. When we say pressure, it is the force exerted on a certain area. So, it's force and area. So, sa isa ka area, pag sige nimo siyang banggaan, di ba, may kanabitang example, imuhang nakaisa ka group mo, naghimo mo research, ikaw ang pinaka-bright. So, ang imong mga kauban, relax kayo. So, na pressure ba sila? Wala.
Wala.
Pressure.
Na pressure ba?
Wala
Ang
pressure.
groupmates? Di ba wala?
pressure.
Naman sila kauban
Sila
yung
magkaayo. Oh. So,
Wala,
kinsay
ma'am, kay
na
magsalig
ana sa inyong research? Kinsay na
Wala.
ana sa research?
Dili may tabong. Wala yung mahuman.
Oh. So, ang isa, kay gisaligan siya ang nakatanggap sa daghan kaayo nga trabaho.
Pressure.
So, siya ang pressure. So, another example is, there's 5 friends. Si friend A, friend B, si friend C, si friend D, and si friend A. E, rather. Si A, na siya'y crush. And then, supportive kayo si B until si E. Ningon sila, sige, librihan ti kag kwan, librihan ti kag pamahaw. Ang siya, pamahaw raw, di po ko pamahaw. Kaya ulawon lang kayo siya, so di siya manguyab. Di siya makikila-ila niya. Siguro ba siya pag ingon lang og hi. So, ingon siya, dili gid na ko kaya. Tapos, human, ang isa pod, si friend C, siya, sige, librihan ti kag pang ML. Isa kasi mana. Kinsagoy dili. Ay siya, sige lang. Kuan man ko, I'm a good student. Study first before ML. Karon ingon pa na isa. Librihan ti kag paniudto, ingon si D. Giahak na. Pamahaw paniudto plus ML burag at na gidto. So pero siya dili gid mas labaw gid nga akong kaulaw. Si E siya, sige, bye. Ako'y panihapon di ba isak si bana siya. Dako ana kay sa ko ba save oy. So naunsa day si A. Di ba gi-push siya? Na pressure siya. Kay gipagtulod-tulod siya sa iyang mga kauban. Sila ba tanan na pressure? Sila ba tanan na push? Wala.
Turang isa.
Yes. The friends exert force to A. Si B until E, nag-exert silang force padulong kay A. So, si A naman ang naka-receive sa force. So, si A lang ang ma-pressure. So,
Good morning, ma'am. Sorry I'm late.
It's okay. Good morning. So, si gas exerts pressure po di ay. Asa siya mag-exert of pressure? Sa wall sa iyahang container. Dito siya magbangga-bangga sa wall sa iyahang container. That's why it exerts pressure. gases mixed with one another from a homogeneous mixture. So, if you have carbon dioxide, nitrogen gas, and oxygen gas in one area, dili na sila mag-combine. Dili na sila mag-react. There is no reaction, but they will only mix. And they will not just mix. Dili na sila maggrupo nga, ay, kami tanan din kay carbon dioxide, kamo dira nitrogen, kamo diri oxygen. Kay dili bita mo ginhawa nga diri ko nga area kay naa si oxygen. Diri na sad ko kay nibalhin si oxygen. Dili biya, di ba? Ginhawa anywhere. So that is because gases mixed homogeneously. Next, the pressure of a gas depends on its temperature. Nga naman, we go back here. We go back to this example. If you heat the container, what do you think will happen to the molecules?
Ang movement mapaspas.
Very good. Because
sila.
that explains kinetic molecular theory. So let's go to kinetic molecular theory or the KMT. Wala, lagi na ko ni siya sentence. So, the kinetic molecular theory just describes the behavior of the gases. Kulag S. Dili gas, but the gases. Pakibutang na lang ko sa yung module na nag-S. So, what are the assumptions or postulates? Okay. Theory pa man siya, so we have the ideas to be written as postulate. Unless it is a law, then we have these particular items to be called facts. So, kay theory pa siya, we call it assumptions or postulate. Nasabtan? I hope you understand the difference between a postulate to a theory to a law. So first, gases are composed of very small particles called atoms or molecules. The distance between gas particles are very great that the volume of the gas is mostly empty space. So, di ba? Dili man ta maglikay-likay kay naay gas molecules. Diri ra kung dapita mo agi. So, mostly makadire-diretso ra taglakaw. Walay mo bangga sa tuwa except if the hangin is very very kusog ug dagan. Malabay gyud ka labaw nagwangkig kay kanak. Mahimo kang kalit. Hikta na lang dayon ka. Para
Dili mapalid ang one cake, mama.
Ayaw,
Hindi ka kaingon. Sa mga on, gitaaw.
Ouch, ouch.
Aloy. Next. There are no repulsive or attractive force between the gas particles. So, kay wala may repulsive, wala attractive force, that is why they do not interact with each other. So, bahala ka dira carbon dioxide, I'm still oxygen. Dili bahala pag magbangga ay sila dagway. Dili sa tagani, di ba? Pag ang chemical reaction takes place when there is collision between the particles. So, bahala pa o daghan kay nag-collide.
Walay reaction.
Walay reaction because there is no repulsive and attractive force. They will just bump. Mura bitag julin. Kita mo ng julin. Kung magbangga ang julin, they will just move away from each other or they will just ang isa kay or ang isa.
Good morning, ma'am.
Like, good morning. So,
ma'am, wala ang kuan mo may signal. Tao, nagi ko ilalo man ang kuan, ma'am.
It's okay.
Ingan.
Very good. Alam, partner mo ni Joy. Kasi Joy, kinapod sa ilalom sa trees.
Partner, magina sila, ma'am.
Ala. Sige na, dito maglangay kay 4 minutes na lang tahoy. 4 minutes.
Easy mo. Sure mo ha?
So there are no repulsive or attractive force. That's why they do not react with each other. So gas particles are in constant random motion. So maskin pag bugnaw or mainit, they are still in motion. Collision between gas particles are on the walls. Nganong unsa man akong gipangyaw-yaw nganong both the walls. On the walls or on the walls
Word.
of the container are perfectly elastic. So when we say perfectly elastic, wala siya na-transfer nga energy or wala energy nga na-loss. So pwede siya nga, di ba kanang Julin, pag magtira ka, pareha sila mag-go to opposite side or ang isa, ang iyahang speed mabalhin sa isa siya mag-stop, ang isa mo dagad. So that is perfectly elastic. No energy of motion or kinetic energy is lost. So it could be transferred or kanang
Silang
contain
duha.
lang nila. Yes. Or gibahin nila ang kinetic energy. The kinetic energy of the particles depends on the temperature of the gas. That's why in its particles, in here, it says that the pressure of the gas depends on its temperature because their motion, their energy depends on the temperature. Just imagine, at nung time, naligo ka sa dagat, and then wala kay chinilas, kailangan imong mukhaon kay gigutom na ka. Unsa kahay imong bation pag muagi ka sa balas? Sa untong tutok.
Init, magdagandagan ka.
Very good. So you will not be walking with kanang sa taga ni Barbie pang Miss Universe nga napakay pa slow-mo. Dili ka mag-ingon naglakaw or else mapaslo tang imong tiil. So you will run as fast as you can. So inana po ng particles. If they are heated, they move very, very fast. Their kinetic energy or their energy in motion increases. So when the energy increases, their speed also increases. Now, there are two types of gases. We have the ideal gas and the real gas. Now, what is an ideal gas? An ideal gas is one that follows all the conditions of the pressure and the temperature. So if the pressure increases and the temperature increases, their speed also increases. But when we say real gases, with the change of temperature, they do not change their motion. Instead, they change their phase. Example, water. Di ba water could be also a gas? We call it what we call
Ma-evaporate on
hydrogen oxide when it's water. I mean, when it's in gaseous phase.
Water vapor.
Bong, vapor lang food. Ay, napila si
Vapor
water.
aday, ma'am. Sorry, ma'am. Sorry, ma'am.
So, the vapor, when you lower down the temperature of the vapor, what do you think would happen to the vapor?
Balik siya sa water form.
Okay. So, hydrogen oxide from vapor turns into water. Diba? In liquid phase. That is real gas. But when we say ideal gas, like helium, kanabitang ibutang nila sa balloon, nga mulupad ang balloon.
Pero mulutaw.
Kanang mulutaw